The normal curve comes into play when we have data that is normally distributed, and it gives us a really valuable use of the standard deviation. Let's take a look at sort of a generic normal curve and how the data breaks down within that curve. I'm hopeful that this diagram looks familiar from your book or your notes, and we're going to talk about it a little bit. This is a generic normal curve with the mean right here in the middle, and we've broken it down into a line that's drawn at 1 standard deviation above the mean, 2 standard deviations above the mean, 1 standard deviation below the mean, and 2 standard deviations below the mean. And what this does is it sections our curve, the area under our curve, into little regions. And because of something called the 68, 95, 99 rule, this tells us that how much data is within each of these little regions that we've created on our diagram. For example, between the mean and 1 standard deviation above the mean, that's where 34% of the data is located. Between 1 standard deviation above and 2 standard deviations above the mean, that's where 13.5% of the data is located, and so on. What we're going to do is we're going to use this curve with this information to solve problems. Now, a lot of times students say, how do you know that's how much data is in between each of those locations? Well, the way that we know is because we are told we have normally distributed data. And if we have normally distributed data, then that means it fits a curve like this and it has these properties. Let's take a look at an example. Okay, here's an example that involves several questions. A set of normally distributed data has a mean of 70 and a standard deviation of 5. And then we have 4 questions that we're going to answer. The first thing we want to do, as soon as we read that, is draw a picture of this curve. So we will draw in our normal curve, and the mean goes right in the middle, and that is 70. Excuse me. And we're told the standard deviation of 5. So 1 standard deviation above the mean is going to be at 75. 2 standard deviations above the mean is going to be at 80. 1 standard deviation below the mean is going to be at 65. And 2 standard deviations below the mean is going to be at 60. You can draw 3 standard deviations above and below the mean if you'd like. We can go ahead and put that in. 3 standard deviations above would be at 85, and 3 standard deviations below the mean would be at 55. And so there's a very complete normal curve that meets the description of the data we've been given. It's normally distributed, the mean is 70, and the standard deviation is 5. Now we've just got some questions to answer. The first one, what percent of the data points are above 65? So that's going to be everything on our diagram from here all the way to the right. Well, there's a few ways we can go about this. One way is by, well, this is 34, this is 34, this is 13.5, and then everything to the right of there. All of the rest of it is 2.5. And we could add those together. Of course, another approach that you might want to consider is, well, wait a minute, 70 is the mean. And when I have normally distributed data, the mean and the median are the same. So I know that to the right of 70 is half of my data. So if I take the 50% that's to the right of 70, plus the 34 that's in that little region right there, and add those together, I can see that 84% of my data in this data set is above 65. Let's look at the next one. The next one says, what percent of the data points are below 70? This actually turns out to be a pretty easy question, because 70 is right in the middle of my curve. It's the mean of my data set, which, because it's normally distributed, means it's also the median of my data set. And I know that half of the data points are below the median. So what percent of the data points are below 70? Well, 50% of them are below 70. The next question, what percent of the data points are below 60? Now we've got to think about this for a minute and think about our little individual regions. There's 34. This is the 13.5, and then from here all the way back to the end is 2.5. So less than 2 standard deviations below the mean is this piece of my graph right there, which is 2.5% of the data points. Finally, what percent of the data points are between 60 and 75? Okay, let me do some cleanup here. Between 60 and 75, and since this is our last one, I'll go ahead and draw on here and not hesitate about that. Between 60 and 75, so that is all of this part of my normal curve. I just have to remember, well, 13.5% is in there, 34% is in there, and 34% is in there. So if I add these together, that'll give me the percent of the data points that are between 60 and 75. Let's see, 34 and 34 is 68, and another 13.5 means that 81.5% of the data points are between 60 and 75. Most students are real comfortable working with the normal curve. The main thing is just draw the curve and put on all your labels and then go back and answer whatever questions you need to answer.